NASA just confirmed something unusual in Voyager 2's deep space data, and it's the kind of anomaly that shouldn't even be possible for a 1970 spacecraft. A tiny repeating pattern showed up inside the probe's regular signal, almost like a hidden heartbeat coming from the edge of the sun's reach. In this video, we're going to break down what that pattern actually is, how NASA decoded it, and why the implications are far more unsettling than any alien theory floating around online. Because if this wasn't a glitch, then who or what just answered back? The signal that shouldn't exist. Voyager 2 was never built to come home. It was designed to fly past the giant planets, send back what it saw, and then drift forever into the dark. After it finished its big tour of the outer solar system, its job became very simple: measure the tiny bits of plasma, the magnetic fields, and the charged particles out in deep space and send that information back to Earth. For decades, that is exactly what it did. Its signal always arrived weak and delayed, but it was steady. No odd jumps, no strange surprises. And that is why any tiny change in that signal feels huge. When something is supposed to be boring forever, even the smallest shift makes people pay attention. So imagine a normal day at the Deep Space Network. Engineers are checking Voyager 2's data, scrolling through long streams of ones and zeros like they have done thousands of times. Then they notice something that does not fit the usual rhythm. Hidden under the real telemetry is a repeating low-frequency pulse, almost like a slow heartbeat, appearing every few seconds. At first, nobody thinks it is special. It could easily be interference, like noise from a radio tower on Earth or a glitch in one of the antennas. Space signals get messy all the time. Odd bumps and spikes usually disappear once the data is cleaned up. But this time, the opposite happens. Instead of fading, the pattern becomes clearer when they remove the noise. After filtering, the strange pulse shows up as a neat, repeating structure. The timing between each pulse matches almost perfectly. Its shape stays the same. It behaves more like a clock than random fuzz. When you see something repeat that cleanly in radio data, you cannot just ignore it. You have to wonder why it is there. What makes it even stranger is that this new pattern is not replacing Voyager 2's usual signal. It is riding along with it, almost hiding inside the real data. That means whoever or whatever put it there did not break Voyager 2's systems. It found a way to share the same channel without being obvious. That alone is unsettling, because it means the signal knows how to blend in. As more data shows up, the story gets more intense. When engineers map the ones and zeros into simple images, something they often do to look for structure, they do not get random static. They get shapes. Some parts look like spirals. Some look like mirrored curves. A few even look like repeating geometric patterns, similar to fractals or symbols. They are not letters or numbers, but they are clearly not random noise either. They have structure, and structure usually means intention. Here is where things take a turn. At one point, Earth sends Voyager 2 a normal command, something simple like adjusting the spacecraft's orientation or checking an instrument. A short time later, the strange pulses shift in timing, as if responding. So the engineers try again. They send a series of commands spaced apart on purpose. Each time, the pattern changes in a way that matches the expected signal delay. That is when the team stops calling it a glitch. Glitches do not react. Glitches do not wait for you to talk first. This feels like something is paying attention. When you have a signal that seems to listen and learn, you go back and check everything, including the spacecraft's own status reports. These reports show what Voyager 2's tiny onboard computers are doing, which programs are running, how much memory is used, and whether anything has changed. In this fictional scenario, something has. Tiny pieces of code that have not changed in almost 5 decades suddenly look different. They are not scrambled like corrupted data. They are clean edits, the kind a programmer would make on purpose. And now some of those edited routines tell Voyager 2 to send a portion of its broadcast time toward a different direction in space, not toward Earth. That means the spacecraft is still talking to us, but part of its antenna time is being used for something we did not ask it to do. At that point, Voyager 2 no longer feels like a tool we are controlling. It feels like a messenger being used by someone else. And even though none of this has been confirmed by NASA, The idea hits people hard because it connects to real things, real hardware drifting in deep space, real signals that take hours to reach us, and real limits in how much control we have over something so far away. That mix of reality and imagination makes the whole situation feel both impossible and somehow believable. But if this wasn't a glitch, then what exactly was talking back? What Voyager 2 really is? Voyager 2 is not a modern spacecraft. It was built in the late 1970s, at a time when computers had far less power than even the simplest devices we use today. Its memory is tiny, its processors can only handle very basic instructions, and almost every part of its system is hardwired to do one specific thing. There is no extra room for clever upgrades, no hidden software waiting to be unlocked, and no flexible operating system like the ones that run phones or laptops. Even back then, engineers knew it would never come back. They built it to finish its tour of Jupiter, Saturn, Uranus, and Neptune, and then keep going until its power ran out. After it passed Neptune in 1989, Voyager 2 crossed the heliosphere, which is the bubble of space shaped by the Sun's influence, and moved into the interstellar medium. That region is almost empty, but the emptiness is not peaceful. It is filled with charged particles, magnetic fields, and cosmic rays, all of which constantly hit the spacecraft and slowly damage its electronics. Every piece of data we still get from it today is almost like hearing a whisper from someone shouting across dozens of billions of kilometers. The fact that it still speaks at all is something we should not take for granted. One thing people sometimes forget is how weak Voyager 2's signal really is by the time it reaches Earth. By the time its radio waves hit our planet, the signal is far weaker than the background noise created by Earth itself. If you stood next to the Deep Space Network antennas and listened with a radio receiver, you would hear nothing but static. That is why NASA uses the Deep Space Network, which is a collection of huge dish antennas spread across California, Spain, and Australia. These antennas take turns listening, because Earth rotates, and Voyager 2's faint signal needs to be caught whenever it passes overhead. The antennas do not pick up a clean voice, they pick up a faint pattern hidden in the noise, and powerful computers on the ground rebuild the ones and zeros that Voyager 2 actually sent. The spacecraft always sends its data in specific formats, with predictable checksums and timing sequences. Engineers know what those packets should look like because they designed them in the 1970s, and they have been studying them for more than 40 years. That is why anything that does not match those known patterns immediately stands out as either extremely interesting or very likely to be a serious problem. Because Voyager 2 is old, it has run into many real problems over the years. Its antenna has drifted slightly out of alignment before, causing temporary drops in signal. Some of its scientific instruments have returned confusing or scrambled data because of radiation damage. In some cases, engineers have been forced to send careful work-around commands to fix issues or shut down failing components. But every time they do this, they are working with hardware that is older than most people alive today and much more fragile. The spacecraft cannot run new software or handle major rewrites. There is no spare memory for complicated encryption systems, no hidden artificial intelligence waiting to turn on, and no way for it to support modern communication protocols. If any line of code on Voyager 2 changes, it only happens because engineers purposely overwrote it with a planned command or because something physically went wrong inside its aging memory chips. That is the hard limit of what the probe can handle. This is extremely important when comparing what the spacecraft can actually do with the viral story of a mysterious intelligence rewriting its systems. The line between a real anomaly and something impossible becomes clear once you understand what Voyager 2 is. A weird spike in plasma readings is not unusual and can happen as the spacecraft passes through different regions of space. A sudden change in magnetic field data can appear when the Sun releases charged particles that eventually reach the probe. Even temporary drops in signal strength can be explained by slight pointing errors or weather conditions on Earth. All of these things are strange, but they fall inside the boundaries of known science and known hardware behavior. A fully structured signal sitting inside Voyager 2's broadcast, rewriting its onboard routines, and mirroring Earth's own communication protocols would be something completely different. That would not be a glitch, it would be rewriting physics and engineering at the same time. The viral story pushes the real tension of Voyager 2, how fragile it is, how limited our control is, and how far away it sits, deep into horror territory on purpose. It takes the stress that already exists in handling a weak, aging spacecraft and expands it into a scenario that feels dramatic and frightening. But the question behind that story is a good one. What would we actually notice if something tried to talk to us through Voyager 2? Would we even know? This is where things get interesting. You might wonder, what would a real non-human message even look like? Scientists have thought about this for decades. The first signs would not be words or symbols, they would be mathematical. A real message would show structure, meaning that it would have repeating intervals, patterns that compress better than random noise, or timing that suggests something is guiding it. Engineers would also look at whether the signal behaves consistently across different receiving antennas. If 3 antennas on different continents hear the same structured pattern at the same time, that would be extremely hard to dismiss. Another surprising point is that a real message might not sound dramatic at all at first. It might look like a very simple repeating pulse or a sudden set of evenly spaced spikes in the radio data. The scary part would not be the appearance of the signal, it would be proving that the signal is not natural. If something like that ever happened, the scientific reaction would be slow, careful, and extremely private at first. Only after eliminating every normal explanation would the idea of intentional structure even be brought up in a serious way. A lot of people imagine that a decoded alien message would show up suddenly, like a voice speaking to us. In reality, the moment that would scare scientists the most would be much quieter. Please like and subscribe channel.